Now, is this a valid string? Yes, this is a valid string because there is an opening bracket and correspondingly there is a closing bracket. So this is valid, or you will say true. Okay. Now, if you look at this, if I give you a string like this, square bracket, flower bracket, this string is also a valid because whenever you are opening one, you are closing it properly with the same type, square bracket, flower bracket, it is true. Okay, again true. That is the second test case. Now if I give you something like this, okay, this, what will you say, is false because what you have is a square closing bracket. There should be a corresponding square opening bracket which isn't there in this question. So you will say false. So the answer will be false. Now let's take yet another example. Let's say I give you a string like this. What will you say? Is it valid or it is invalid? Valid or invalid? It's valid. Why is it valid? Because if you see, I have an opening flower bracket. Then I have this bracket. Fine, no problem. It's an opening bracket. The problem comes if I have a closing bracket and I don't have a corresponding prior to that, I don't have a corresponding closing bracket. Corresponding to the appropriate closing bracket, I don't have an opening bracket. Now this will be same, this and this is okay, and once these two are completed, this can close this. Okay, so this is a valid string or true string, valid or true. The answer is, in our case, you have to give the answer as true. Now, I will give you another example. Suppose it is like this. Okay. Is this valid? This is not valid because you start with this, no problem. Opening brackets, never a problem. Never a problem. Now you look at a closing bracket. This is a parenthesis. The corresponding opening bracket which has just been opened is square bracket. This can't pair with this. So we say it's a false. Okay. Now, the first thing, this is a string question, but it is also a data structure question. Okay. Now let me ask you, now in the last semester we did different kinds of data structures, correct? We learned something about a tree, about a graph, about a stack, about a list. What kind of data structure this problem needs? Good, okay. Sound is also good, okay. So, yeah, so it's obviously a stack question. Now you'll ask, what is so obvious about it? What makes you think it's a stack? Because you see, I am comparing where do I do a comparison? Only when I see a closing bracket. Okay, when I see a closing bracket, then only opening can open anything. We don't check anything because it's an opening thing. If I close something, the guy previously seen should be a corresponding open. As long as that is there, it is valid. At any moment, if this gets violated, then it is wrong. Okay, so now let's proceed with the topmost data. Let's proceed with the topmost string, the one on the screen which is topmost. I start scanning this list from left to right. Okay, left to right means left to right. Okay, so what do I get first? I get a flower bracket first. When I get a flower bracket, what do? I check, is it an opening bracket or is it a closing bracket? What kind of bracket is it? It's an opening bracket, right? Opening bracket, I don't do anything. I just push it into a stack. So right now my stack looks like what? Imagine my stack. It has an opening bracket. Okay. Let me just show you how I would go about solving it, because it's early days, we are showing it. After that you guys need to figure out. Okay. Now I take this and I have a stack. Let's see how I build the stack. Okay. Okay. So I look at this character. This is a string. I can always access a character from a string using char add, or you can convert a string into an array of characters using a method called toCharArray, which you can look up in the documentation. There is a method which gives you an array of characters. And I look at this bracket. So when I look at this bracket, I see it's an opening bracket. I know in my code I have three kinds of brackets only. So this is an opening bracket. So I say, I put it blindly onto the stack. I push it onto the stack. Then I see this. It's an opening bracket of some kind. Blindly push it onto the stack. Okay. Then I see this. It's a closing bracket. If it is a closing bracket, then I have to look at the stack. How do I look at the stack? There is a method called peek. On a stack, peek. Peek is what? Just look at the topmost element. Don't pop it. If you want, you can pop it, but no need to pop it. There are two methods, remember, on a stack. One is a peek, the other is a pop. Do I have to peek? Do I have to pop now? No. First let me peek. See whether it's of the right variety. So what am I holding in my hand? This. What do I have to check for? Who is at the top of the stack? Top of the stack is a good guy. He matches my requirement. If he matches my requirement, I can pop him from the stack and no error. So that's all. There is no error because it's a match. I am able to pop somebody from the stack. If I peek somebody, speak on the stack and find somebody who is not compatible with me, then I have to flash an error, obviously. Okay? We'll see that in a moment. Then I have an opening, I have processed this, and right now the stack is only this flower bracket, Now I look at this opening bracket. Opening bracket, no logic, just put it under the stack. So just for clarity, now my stack is going to look like flower bracket initially, and now I have this character. This is an opening bracket, so I just blindly put it here. Now I get a closing bracket. See, I got this. I got a closing bracket. Now I have to check. I have to peek at the stack. Do I see a guy who is compatible with me? Yes. I see this guy who is compatible with me. So I knock this off. I pop the stack. Now my stack is this. Now I proceed to the last character. At the last character, if now I see this guy, I see him at the top of the stack. He is compatible. I pop. Okay. So if everything is matching, then my stack should be empty at the end, because everything would have popped off, everything would have matched nicely, and I would get an empty stack. That would be the indication that my code has completed successfully. Then I will return a true. Okay. Now let's work it out for, we worked out for here, let's work it out for this scenario. Okay, this scenario. Let's see what happens. So let's see the development of the stack. I am looking at this scenario, please. So open bracket goes onto the stack, then open bracket again goes onto the stack, open bracket again goes onto the stack, close bracket. Now I peek at the top of the stack. Now I am here and I am peeking at the top of the stack. I am seeing this guy. Is this guy compatible with this guy? No. Answer is right there. Return false, over. You don't have to do anything more. The moment I find an incompatibility, I just say false. Okay. Now there is just one situation which you might want to think about. This, and this. What should happen in this case? What will happen? First, I will see this. It's an open bracket. Any kind of open bracket, put it on the stack. Now I get this, yes, I peek at the top of the stack, compatible, push it, pop it off. Now now I am here. Okay, I put it, open bracket, blindly put it onto the stack. Now, what will you say here? Remember, we never had any problem. But what is the problem here? What will I say at this stage? Will I say valid or invalid? I am asking you. Invalid. Why will you say it is invalid? Because at the end of the expression, my stack should be empty. Is it empty? So that means there is a mismatch. If at the end of my expression, so there are two things which have to happen. If I have to say valid, when I reach the end of the expression, I should have stack completely empty, and obviously the fact that I have reached the end means I did not have an anomaly before. So if there was an anomaly before, right there I would have said false and code would have finished. Okay. So this is the question. Now what data structures you need to engage? Stack. Stack of what? Char. This ideally it could be a string also, but then you'll have to convert it into a string and check. Easier is stack of char. You can create a stack of char, and the operations available on a stack are, did I go through them at any stage? No? Okay, we can look at them very quickly. There are only 3 or 4 operations on a stack which Java allows. What do you think the 4 are? Push, pop, peek, empty. Yes? There is one more operation called size. So instead of checking empty, you can also check for size. It's the same thing. Okay? But generally we don't use size because sometimes it's implemented, sometimes it's not. We always check for empty. So we'll just look at stack java.util.star. Yeah, it is in that package. So we'll look at stack. Look at this stack. Yeah, you can come down. I'll just go through the operations. See, there is an empty operation which returns a boolean, a peek which will return an element of that kind, pop, push. There is also a search, but people don't use a search. Achha, there is no size here. I was wrong. Size is there in C++. Okay, it's not there here. That's what I said. Sometimes size is there, not there. Search is there, but you don't need search most of the time. Now we'll go to some geek for geeks, and I'll just show you how to use a stack. Yeah, this is just to summarize what you will need. Okay, let's look at the way it is done. Oh, they are directly showing you operations. This is not very good example. No, that is implementation. Yeah. Okay, this is how you can create a stack. See this code, stack integer. Now that is for a stack of integers. You say stack of char, C-H-A-R, C capital. Because those are the, C has to be capital please. Don't say small. Small is a primitive. Primitive is not allowed. Char is the wrapper. We'll discuss that separately. But just say char uppercase, just like integer uppercase. I'll tell you what they are. Okay. Sorry. It is character, not char. So say stack of character, not char. Not just like integer. You just say new stack, angular bracket, then the push operation is shown. Here it is push of integer, you can push a character. And then, well, here he is checking stack is empty. There is no pop here. But you can also see the pop. This is all push. Okay, this is the pop. Now, if you have declared the pop as a stack of char, you don't have to do the casting. You can directly get the char. Okay, you can directly get a char from the pop. So, okay. So now let's go back to the question where we are asking you to write the code. So now your input to your function is a string. How do you read string from the user? Scanner dot, it's not next int. Next line you can do, or next you can do. Difference between next is, it will stop at the first space. If you do next line, and if there are spaces in the input, you will be able to read the whole thing. So you should use sc dot. In this case it doesn't matter because it's one string. So it doesn't matter if you say next line or next. It will both give you a string because we are only giving you a string without spaces. The question or difference comes only when you are giving spaces. In this question there is no space. So the way your code will start is you will say next. You will create a scanner, you will say next. Then you will read the string, we will give you that string, so you will read the string. And once you get the string, what will you do with that string? You will convert, if you want you can convert it into character array. If you don't want to use char, at, I, all that, I showed you that method. So a lot of people who are comfortable with C or C++, convert that string into character array and then use it as a character array. Nothing wrong with it. Okay? So that is something you should do. Now once you have a character array, you will also create a stack in your program. So stack of characters. So learn how to create that stack. You will do that next. Once you create the stack, what will you do? You will start going through the character array. If you have converted the string into character array, you will go through the character array. Every character array has a length parameter, or you can just say for each char C in character array. You can use the enhanced for of Java also. So for each char C in character array, what will you do with each char? Check what kind of character it is. So there you will have to write code. If C is equal to this kind of open bracket, or that kind of open bracket, or that kind of open bracket. First check for open bracket. If it is any open bracket, simple, what you do? Blindly push the character into the stack. There is nothing you have to do because for open bracket you don't check anything. If you have a closed bracket, however, then you have to check. If it is not an open bracket, it will be some kind of closed bracket. If it is a closed bracket, then you have to check at the top of the stack, peak. If you find the right character in peak, very good, pop it and proceed to the next character. Very simple code. Okay. Again, it is not necessary that you should use a stack, but if you don't use a stack, code will get complicated. Stack is this question is tailor-made for stack. Okay. Later we will start adding inheritance, interfaces as we pick them up. Okay, since it's the first few questions, we'll solve them in front of you. And as I solve, please understand what I'm trying to do. 28. Okay, we'll start now. Valid what's it? Then you'll have to call the same name as the class. Parenthesis, okay. So we'll say class valid parenthesis. Because there's going to be only one main class, we'll do it that way. Okay, now we have the signature already for the public static void main, so you can just take it. We have to import one package, you are aware. So, which is the one? java.util.star, because all the scanner and all the rest will come from there. So it's always better to import java.util package. We are importing it. So we'll first create a scanner. Scanner sc is equal to new scanner system.in. Now you know system.in is connected to your keyboard, so that is what we are going to read the data from. So the scanner can scan anything. Actually, right now we are using it to scan the keyboard. It can scan a network, it can scan a mouse, it can scan many other things. We are not interested right now. So string str, that is a string which the user is going to give. We can say next line to be safe, but in the present circumstance, even next should work, because anyway we are reading a string. So, okay, I hope everybody is clear so far. We have created the scanner object, and using the scanner object we have read the line from the user. Now we have to create our own data structure and work with it. So we have to create a stack. Okay, so we will create a stack of character. This is how you create a stack of character. We have to say character This is called a wrapper class, which we use in Java, but it's actually internally a character only. So we say stack character st is equal to new stack. Now after new stack, you just need to give angular bracket. If you want, you can say new stack character completely, and or you can just say new stack angular bracket. I think that is easier to say. Okay, this is also fine. Please be sure to give the angular bracket, empty angular bracket, so it knows that it's a stack of something. That something comes from the left hand side, because we created stack of character. The right side also creates a stack of character only. So now a stack object is created on the heap, which is empty as of now. Are we clear so far? Yes? Okay. Now what do we do? Now there are two options. I can go through the given string str by using char@, or if you don't like that way, we can convert that into an array of characters. That is also allowed. Those of you who are comfortable with dealing with array of characters, we can deal with array of characters. Or we can say char@I. So, I don't know. What do you like? You decide. Okay, character. Array of characters. So, we will create char SARR square bracket is equal to, we are converting that string into an array of characters, str to char array. Is this correct? Oh yes. Converting a string into an array of characters. This is if you want. Otherwise you can go through the string and say char@I. That is also fine. So I converted that string into an array of characters. Every array in Java has a variable called length. Okay? I didn't create it. All arrays in Java have a public variable called length. So we are going to use that variable and iterate through this array. So we are going to say, now for loop. For, now our main loop starts int I equal to 0, I less than SARR dot length, I equal to I plus 1 or I plus plus. Okay. So we started an array and we got an array from the string. Now we have an array of characters and now we are going through that array one by one. Okay, what is our rule? If a character is one of these three, which three? Three different kinds of open bracket. We don't do anything, we don't do any thinking. Agreed? What do? Just push that character onto the stack. Very simple logic, no? So watch what we are doing. For int I equal to 0, I less than SARR length, I plus plus. If SARR of I, we have to write a better if, SARR of I equal to open bracket, open three different kinds of brackets, yeah. Okay, this or SARR I, yeah, we can repeat that, SARR I, this kind of open bracket, or SARR I, this kind of open bracket. Are you all getting my logic? See, that open bracket we are putting in different kinds of open bracket, we are putting in single quotes. Java single quotes means single character, string literal, like in C or C++. Okay, if SARR of I equal to any of the open brackets, what do? We blindly push it onto the stack. We don't have to do anything. We'll just blindly push it onto the stack. So st dot push what? That SARR of I, whatever it is. Okay. If it is one of these, we'll blindly push it onto the stack. Okay. And remember, our string doesn't contain anything else other than open brackets or close brackets. So there is no need to check anything else. It's given in the question that our string is only a combination of brackets. A string of brackets, and we are checking whether it is matching or not. So if SARR is any of these, then we don't think twice, we just check, we just push it into the stack. Else, what do we do? Now, it is not one of these, so it's some kind of closing bracket, correct? Now we have to write appropriate logic. You can either write a nice switch case or you can write an if. If, you have to write 3 ifs, right? Because each one you have to check for the corresponding story, okay? You could optimize it a bit, but doesn't matter. If SARR of I equal this kind of closing bracket and what? What should I do now? What should I do? I should peek at the stack, no? Without popping. Yes? I'll peek at the stack. How do I do that? I say st dot peek. What will it give? It will give the whatever is the topmost character. Yes? Right at the top of the stack. Everyone knows what is a stack, no? Okay. So st dot peek. If st dot peek not equal to the corresponding open bracket, then at this stage itself we can say, we can do the two things, that is we break out of the for loop and we can say we have to print something, true or false. Okay. So at this stage what will we do? We print true, because for true to be true we have another logic. Okay. Anyway, doesn't matter. So we'll say break, but before saying break what will we do? Print false. It's violating, no? Is it a violation or not? It's a violation. So system.out.println, okay, we'll say false, whatever is the expected. If false is small f. So does everybody buy this condition, what we have put there? No, yes. Is it work correct? We are checking if the character that I have is a closed parenthesis, then the corresponding guy at the top of the stack has to be an open parenthesis. If it's not there, then it's a violation. I come out and say false. Okay. Now, else. The else is for this if. Else, what does it mean? What does it mean? Now, the tricky part now is that else will mean any one of those two conditions is false, right? No, yes, I think. So, what should we say? If st.peek, that it comes here when the top condition is not true. That will happen even if SARR I equal to some other closing bracket, correct? So can I improve that if? Or can I write this? Of course I can always do this. Okay, fine. So only thing is I have to confirm that I am coming here because the condition at the top is not fulfilled. Okay. So if SARR I, okay, write that. Else, else if we will have to write, because we don't want any trap there. Else if SARR I equal close bracket, because there are many more conditions coming, and st, actually I should write the other way. If st.peek, I think I'll change the logic a little bit. Let's write the other way. Let's not write a violation. Remove else if st.peek equal, go to 14, we'll say not equal to, you remove, say equal, the corresponding thing, Then let's handle this, then we'll write the else. Okay, that is fine. Now if this is there, okay, remove system.out.println false and remove the break. Okay, now we have a match. Okay, please understand, I am just changing it a little bit. If SARRI equal closing bracket and peak is opening bracket, we are fine. Only thing we now have to do is what? We just have to pop. Correct. We have to pop the stack because now I have to get rid of that closing bracket, opening bracket. So pop, I get rid of it, and that's it. No? That's all, no? Are you guys with me? I'm just writing. Okay, you have to follow as I write. So if I have a proper match, I have the current character is a closing bracket and I have a corresponding opening bracket at the top of the stack. That's very good. That means I just get rid of it and I proceed. Right? Else if. Okay. Else if. Now check the second way of thing. Else if SARR of I equal what? The other kind of closing bracket. So I'll say, yeah, no Baba, closing bracket, flower bracket and st.peak is opening bracket, opening flower bracket. Okay, then what do? That is also a condition for a pop because now also there is a match. Okay, so I'll say else if SARR of I equal to open bracket, st.peak is equal to close bracket. So I have got an open bracket and there's a corresponding, I have got a close bracket and I have, there is a corresponding open bracket at the top of the stack. Then I am fine. I pop. Else if, what is the third condition? Same thing with the third kind of bracket, right? Equal, flower, square bracket, closing square bracket, and st.peak. I think peak, we have to put the method. st.peak is the method which does a peaking on the stack. Equal, opening bracket. So we have a nice opening bracket at that point. Again I do st.pop. Okay. Yes? Any flaw so far? You are saying stack is nothing. Now you are, no. You just have one. Yeah, good condition. That is what you are saying? You just have this or just this, one of them. That's a good thing. Then what will happen? My st.peak will give me trouble. Yes, no? See, very good. This is what I want you to think. Suppose the string is only closing bracket. Just imagine, only one closing bracket or two closing bracket, doesn't matter. And I try to peek on the stack. Yes? I have not put anything on the stack and I try to peek on the stack. What will happen? I'm sorry? No. No, you try to peek on an empty stack, it should give you an exception. Okay? It should give you an error. Okay? So, before I do a peek, what should I do? What should I do? I should check that the stack is not empty. So, the third the peeking should be qualified with the checking that the stack is empty or not. Correct? If the stack is not empty, then only it should proceed to the third condition. Now how do I change my logic to do that? No, in the AND condition only, he's doing it. I'll put another and not stack empty, and not stack dot empty. So will this protect? No, yes. Will this protect us from trouble? It's a good catch. Because if it is empty, it will come out there, it won't go into that if. For the condition for it to enter the if is, pass the if is, the stack should not be empty. And then only I will do a peek. Now this is an important technique, and this is an important way of ensuring that we don't goof up, is that before you do a peek or a pop on a stack, generally it is considered good habit to check whether the stack is empty or not, because pop on an empty stack gives an exception which will abort the program, will not help us. So we'll put that condition everywhere and then only do a picking or popping, whatever. Do all of you, it's a very good point. Do everyone catch this? You guys only did this, right? And it's very important catch, because it takes care of a situation where I have nothing, or I have finished it and then there is just a pending closing bracket. There is nothing in the stack. Okay, so it will have a situation. Okay, now else. After that else. Now let's talk about when will I come here. When will I come here? Many situations. First situation, I have got a closing bracket, but what is in the top of the stack is not corresponding to what I have got. Because you see, everywhere we are checking, if it is equal to, the character is equal to that, stack is not empty, and the corresponding character is not at the top of the stack, then we are not doing a pop. So else means what? Something is not finding the right character. It is not an opening brace, it is some kind of closing brace, but there is no corresponding opening brace at the top of the stack. If it is not there, then I have a goof up. Okay? So there is some violation. So can I say just here, print false? Can I or can I not? It's a good enough situation for me to say false now and declare. Okay, so let's try that, false, and then we will do a break, because we don't want to stay in the for loop now. Break. Okay. Now this takes care of the else closing bracket. Now how long will this go on? Look at my for loop. So I will go on till I reach the end of the stack. Yes? Now what should I check after the for loop? Why the stack is empty or not? Because what would have happened is, I have an opening bracket of some kind, then I have another opening bracket of another kind, and then I have a closure for that bracket. It will close this off. So I will not have this violation. But this is not a valid string. The example that I am giving, is this. What will happen? First, this will go onto the stack, very easy. Then this will, because it's an opening bracket, this will go and sit on the stack. Now I have a closing bracket, which is good. This will knock this off. So now I'll have this, and I have come to the end of my string. Okay? Now just because I have reached the end of my string and the stack is not empty, then I will say there is a problem. Correct? No. That means I have an imbalance still. This also has to be checked. So I come out of the for loop. Now I am out of the for loop because my string is over. Now I have to check. I am out of the for loop. Okay. That's the end of my for loop. Now what do I do here? I can check while or if. Okay. If is good enough. If stack dot empty. Okay. Then what will I say? System.out.println false. No, I think they are saying, I don't know how they are asking for true or false. If it is a similar way, we can print it that way. Okay. If it is a similar boolean, you are right. You can print whatever is the value of stack empty, true or false. Okay. Okay. Now false, else true. We can say it is true. So you will get true only if you have everything, nowhere we have a violation. Through the entire for loop, I am not having a violation, and at the end the stack is empty. Then only I will get a true. Otherwise I will not get a true. I should not get a true also. Okay. Now let's test it out with some strings and see how is it going. Okay. Okay. We'll play with a few strings. Now we'll put one flower bracket, another square bracket. Keep it like this. This is a false, as it should be. Okay. This is a false, no? What I just talked about. Flower bracket, square bracket, open square bracket, close square bracket. Square brackets are closing off. Okay. Now let's do another, try another. Okay. Flower bracket, opening square bracket. Okay. Parenthesis, another closing parenthesis. Okay. Now opening, correct. Square bracket, closing square bracket, closing flower bracket. Okay. Now this is a true. It should be a true. Correct? No. Okay. Are you understanding? It's true. Any other condition you want to try? Only single? Only single close bracket. Which kind? Whatever kind. It doesn't matter. Okay. Single closed bracket. Closed. Why is it printing false and true? It is false. Why is stack empty? I'm sorry? So should we push? No. So now, why is this coming? No, we understand why it is coming. Why it is coming? Because it didn't, see what did we do? We just put a single close bracket of some kind. Okay. Now, what happened is the stack was empty. False came correctly. But at the end the stack also became empty. Okay. So what we should do to, we should put a flag. So in any violation, there is a violation, right? So we should, in any violation, we should put a flag. And we should not simply, while printing true, we should not simply say stack should be empty. Stack should be empty, all right, and there should be no violation. This is a common trick used. In programming we use it all the time, where we'll introduce a flag variable which will set to 0 initially, or whatever, true or false initially. The moment we see a violation, we'll set it to whatever, the other value, and check. Okay? So that will avoid this problem. Okay. So we will say at the beginning of the loop, before we start, now we will say Boolean flag equal to true. Okay. Any violation happens, that is in case of any else, no, in else. See, any violation happens, it will print false, correct? But it will break and print true. Or I can return there, but there is main there, so I don't want to return from the main. I can stop main, you can do that, but generally let's not return from main, okay, because that has other problems later when we implement a method. Yeah, somebody suggested another approach which will also work. You can exit from the main the moment you have a false. That is another way of doing it, but I don't want to do it because I will need main later also in some other thing. I don't want to just exit, okay. So we will say here, after line 24, we will say flag equal to false when there is a violation. Okay. This is a more standard technique. Okay. Now what will we change? We will go to line 30. Else if flag. Else if flag. Flag has to be true for this line to be printed. Okay. Flag will be true if we have not found any violation. Okay. Flag should be true and stack should be empty. Then only it is correct. Okay. Now let's take care of that. Let's see what happens to the other scenario, the one which people pointed out. Just one closing bracket, that's all. Okay. Now it gives a false. What if we have many closing brackets? No problem. First time itself it will give a false. So if you have many closing brackets, okay. Anyway, that doesn't matter because that's a false. Any other condition? Okay. Let's see whether it evaluates. Okay. We get the 100. Okay. Now, okay, does everyone get this code? No, yes. We have to learn every step, every trick. It's not very difficult. We are using a stack, putting stuff in the stack, checking. Fairly easy question. I went very slow, so you should grasp. Okay, now we'll open another. This is not that difficult. Look at the question. It's again on strings, array of strings. Look at the question, analyze it, do it. Think and do it. I will also describe how it can be done. You have to find the longest common prefix among an array of strings. So you are given an array of strings and you have to find the longest common prefix. How do you start? Very simple. You create an empty string, okay? Then go through all the arrays, all the strings in that array. Start with the first string, pick up that, see whether it is same in all. If it is same in all, take it. Okay, now there is a little bit of trickiness here. This part is easy. If you look at that example, F, L is common, so the longest common prefix is F and L. Now, same thing, you look at the next one, even the first character is not common, so forget it. Now there is, I remember a trick here. Sample input, first, Firangi, films, firm. Okay, there is no complexity, there is some other variation of this question which is more complex. So you have to read an array of strings using next. So the input, can we see the input? The input is first 5. 5 means how many strings? That is the number of string array that you have to create and the number of strings that you have to read before you start processing it. It's easy. You can concatenate characters to an empty string. So you start your answer with an empty string. Probably you should be careful with this question. Yeah. Suppose you have flower, fox, flow, no, FL, flower, flow. So what will happen here is, so you can start with the shortest string, I think. You should find out the shortest string and make that as your initial string and pick up characters from that and match. That way your life will be easier. Find out which is the shortest string. On every string there is a length method. So find out, just write a small loop before, find out the shortest string and make that the reference string, and then, because see, if it has to be longest common prefix, it is common, right? So it has to be there in the shortest string. Am I right or wrong? So you start with the shortest string and then proceed. Find out which is the shortest string and make that as your reference and use that for comparison. Your life will become far easier than writing unnecessarily complicated loops. Becomes very easy. How do you find the shortest string? For every string there is a method called length. Go through all the strings in an array, find out their length. If the length is smaller than this, make that the shortest string. Start with null. Okay, we'll start. First check how many finished. Now we'll read as usual, import java.util.star. Okay, we'll create the scanner object. Now in this case, because we are reading a bunch of strings, we have to use next line and then chop those strings using split. I think somewhere some of you may have lost that. So we have to say, first we have to read next in. Okay. So we'll say string str is equal to sc dot next line. Okay. You want to split in the same thing. Okay, then it's okay. Split, then you have array. Then declare array. This is okay. Or you can read a string using sc dot next line. It will come with the spaces. Then split the string on the basis of space. Or look at this line. Sc dot next line. Read that string with spaces. Split on the space, that is the tokenization delimiter, and you will get an array of strings. So str is an array of strings. Is everybody clear? Now this you should pick up. Okay, some of it you should pick up on your own. So string str square bracket is equal to sc dot next line split. We got it. Okay, now what we said we'll do, we'll use a reference string as the smallest string. So we have to find the smallest string. So we'll declare a string, r string, as our reference string, r string, and we'll assign it to str of 0. str of 0. Okay, str of 0. Now what we'll do, we'll iterate through all the strings for int I equal to 1, because I have to iterate from the remaining, less than str dot length. Length is the length of the array I plus plus. Now I'll compare if str of i's of each of their independent lengths, stri dot length because stri is a string, string is also an array. It has a length. Now, on a string, length is a method, not a variable. Now, please see very closely. str is an array. Okay, on that length is a variable. But on a string, also there is length. But length is a method, not a variable. On an array, it is a variable. This is something you should remember in Java. See the difference. On line 7, I am saying str.length, and on line 8, stri is one of the strings. On that I can't say simply dot length. There is no variable on a string. There is a method on a string called length. That's why I have to put those brackets. So if stri length greater than rstr dot length, this is also a string, then we will say rstr is equal to str of I. Okay. Done. Is that enough? If I have a longer string than, no, I should say the other way, no? str of I length is less than then rstr is equal to str of I. Is this correct or the earlier one was correct? This is okay, no? What am I doing? str length is less than rstr length. rstr is the first string. I am finding out the smallest string. So I am saying rstr is equal to str of I if it is lesser. So at this stage rstr will contain, after the for loop, it will contain the smallest string. I am going to use the smallest string as my reference string. Okay. Okay. Now let's say my for loop is over. Okay. Now my rstr contains the smallest string, and now I will use that as a reference to move through all the characters of all the strings, right? Corresponding characters. Now, do I need 2 for loops or 1 for loop? First I have to go through all the characters of a string. The moment I find something is not matching, I will stop, because that will be the minimum, right? So, okay. So, now what will I say? What should I say? I have to go through the entire thing. Now I have to create my result string also, which is the common prefix, right? So how do I create my result string? I can create that. String result, okay, res is equal to, okay, empty. Okay, now what will I do? I will go through the reference string and then examine whether the characters are same. For int I equal to 0, I less than rstr dot length. Okay, rstr is a string, so length is a function. Okay, so I plus plus, for int I equal to 0, I less than rstr dot length. I am going through the smallest string because the longest prefix has to be not longer than the smallest string. That's the logic, isn't it? So for int I equal to 0, I less than rstr dot length, I plus plus. Now what will I do? I will check whether the ith character here is same in all of them. Same as what? Oh, now I am going to compare character by character, right? From rstr, I am going to compare and move forward. So what should I write?
Compare each character and push into the result.
So if it is same everywhere, that is, now I have to start an inner loop on this character. Correct? And compare this particular character, that this particular I of every string. Okay? So what should I say? For j, int j equal to 0, Now I have to go through j less than all the strings. How do I know how many strings are there? I can use n or the outer array's length. So I can use n, right? Where I read the number of strings. Int n is equal to sc dot next. Before doing all this, I should get the number of strings. So I'll go through all the strings. J less than n, j plus plus. Okay. Then what will I do? I'm going to go through each string and check their ith character. How do I check that? With my reference character. If help me, what will I say? str of I, this is the ith, str of j, it's the jth string. I am going to check all the strings. str of j, his which character? Dot char at, good, dot char at I. Should we say equal to or should we say not equal to? Not equal to is better. Equal means, now think a little. If a character is same in all the strings, this ith character is same in all the strings, that if condition, if I say not equal to, will not be violated. Okay, I will say not equal to what? rstr of ith character. rstr. Okay, this is the reference string. So any of the strings character is not equal to that, then I should do what? That means two things has happened, right? I should break from the inner for loop. No? Because the comparison is failing. I should set a flag and break. Because if I set a flag and break, I will know that I have come out of the inner for loop because of some problem. If I have come out of the inner for loop without a problem, it is one thing. If it is with a problem, it is one thing. You have to think. Okay? This is nothing but for loops. So, if str of j char at I not equal to rstr of I, there is another way you can do all this. You can do a substrings. Keep doing substring. But anyway, this is much more robust by itself. So, strj dot char at I not equal to this, then I will make flag equal to false, which I have initially, before you start this, no Baba, no. After line 15, get flag, boolean flag, true. Before every comparison, we will make it true. Okay? Yeah. Now, the moment we find an anomaly, we will say flag, no, not there. Not there. 60, before line 15. Put it there. Then say, if any anomaly is found, then we'll make flag equal to false. Okay. And we'll do a break. Okay. Now, when I come to line, what is the line after the for loop? For loop. Inner for loop. Okay. Put a next line after that. Okay. Now let's think a bit. When I come out of this inner for loop, what does it mean? Why I have come here? Yeah. Why I may have come here? Two reasons, correct? One reason is I finished the for loop successfully. I did not find a single anomaly. When will that happen? When each of the ith character of all the strings, yes, is equal to rstr's ith character. Yes, no? Yes. No, I am repeating, please, you have to understand, because basic loops, we should be good. See, the inner for loop, when it completes and comes here, that is on line 22, inner for loop, focus only on inner for loop. It has come here means what? Either the for loop completed or the for loop break, correct? For loop completed means what? There is no anomaly. Anomaly, there is no anomaly means what? Every ith character of all the J strings is the same. Yes? Then only I will come here. So if I come here with flag equal to true, then it means that this ith character of all the J strings, of all the strings, is the same. So that means it is a good prefix character to have. So what should I do now? Okay. So if flag, okay, flag, then I should say, okay, now I am in the I should say what is my result? RES is equal to RES plus, we have to concatenate it, no? In Java, how do you concatenate? Just plus, wait. What should I say here? RSTR of? RSTR of? I. No, will RSTR of I work? Oh, I shouldn't say RSTR of I. There also, एक minute. I made one more. Line 17. I should say caret, no? I can't refer to it as a... RSTR is a string, no? On line 17, I should say RSTR dot... Nahi baba. RSTR dot caret I, no? Yes, no? I made a mistake there, right? It should be caret I. It should match that caret I of RSTR's I. If it is not matching, I will say flag equal to false. Now come down. RSTR dot, I can't say square bracket on a string in Java. Dot caret, okay, I. Okay. Now what should I do? Now what should I do? Okay, what should I do to the flag? Again flag will become true, no? When I go back. Okay. Am I done? Am I done or am I not? No. Else, if flag is not true, else, that means flag has become false. That means what? It's time to come out of the outer for loop also, no? Arey, you guys need some, come out of sleep please. Else break again. Break. This time it will break from the outer for loop. Because I am done. Okay. Now, I am out of the outer for loop on line 28. Line 28. Achha. After this, what should I do? Print RES. That's what, no? Okay, let's go through the code again, see whether it works. RES. Okay. I mean, this is one way of doing it. People will find other ways of doing it. Okay. Now, I'll just walk through the logic again. I am starting from line 6. It may be, we are also doing it on the fly, so that's how it should be done. Okay. Line 6, string str, sc dot next line. I am reading that line, splitting it on the basis of space. I'll get an array of strings. So when I get an array of strings, they are all sitting in str. So taking that example, str0 may be flower, str1 may be flow, str2 may be something else like that. It will all sit in str. It's an array of strings. Then line 7, what am I doing? I am saying string rstr is equal to rstr of 0. I am just going to find the smallest string of all. So tentatively I am assumed, just like when you find a smallest number in an array, what do? You take the first element as the smallest element and then go through the entire array. We are doing something similar. So we are saying string rstr is equal to str0. Then we are going through the rest of the str. Because it's an array, it has a length variable, and then we are going and checking if stri, each guy's length, is it less than rstr's length? If it is less than rstr's length, then we are making rstr equal to that stri. Okay, that's over. At the end of line 12, rstr will be my smallest string among all strings, because the longest common prefix cannot be longer than the smallest string, correct? The smallest string will dictate how big the prefix can be, because it's longest common prefix. So we have taken the first string, smallest string, as our reference string. That is our rstr. Then we are starting line 13. We are saying res, we are starting with an empty string. And for int I equal to 0, rstr.length, now we are taking that as our smallest string, rstr.length, I plus plus. We are using that boolean flag to find out whether this any character is acceptable or not. So we'll say boolean flag equal to true. Then we are going through all the strings with this as a reference string, j equal to 0, j less than n, j plus plus. Checking whether that particular character in that particular str of j caret I is equal to rstr caret I, it should all match with that rstr character. If all are not same, if even one is not same equal to the reference string, then any one is not same, there is no point continuing, because we have come to the end of commonality. So the moment we find an anomaly, we say flag equal to false and we break from the inner for loop. Okay? And then if we have broken from the inner for loop with a flag equal to false, that means we found an anomaly, and that's why we have come there. So if flag is still true, that means we found this character in every string, and therefore this character is a candidate to be added to the longest common prefix. So then we are expanding. If you see, if flag is true, we are saying res is equal to res plus rstr dot caret I. We are expanding our result, because now this character is common in everywhere, in all the strings. Okay? Else, that means we found an anomaly, we have to stop here. So we say break. Break will break out of the outer for loop also. When it breaks us out of the outer for loop, we are printing the res as it stands. Okay, let's shoot it with some sample data. Okay, so we'll say 3 finding, not taking, sc dot next line not working or what? No, I think we should read it, then do next line separately and then do a split. Just say string s is there, string s, just say s. Now split s and get str. String str array is equal to s dot split on space. Now see what's happening. No, why? Now how did those guys read? For loop. So you are doing next, next, next. We'll do it like that. You are saying take the first one also as string. No, I don't want to. Yeah, that's perhaps will work because treating everything as string. After the fifth line, when we type, we should put the next line. I think he is doing it. When he puts the input, try. That's what you are saying? Before taking the array of strings, cursor has to go to the next line. What he is saying is, while entering, no, press enter. Say 3, enter. Or the enter is probably, no, so now just go like that. But this should not give this problem. Flower, flowing, okay. Oh, you are saying we should say 5 sc dot next line.
After 5 we need to, yes sir.
And then convert that into, I don't want to do that. Just to move the cursor. I don't know why. Okay, we'll try, no problem. Now next, 3, we'll see. It's working that. We didn't know. It should not work like that. No, it shouldn't have to add. No, flush is different. You have to create a file-like object, buffer, and then do a... No, that is not a problem. Okay, let's keep that aside. Okay, anyway. Now this should not happen. Okay, it seems to work though. Whatever the other part, let's keep it aside. I don't know why sometimes it shows that. No, I don't want to read it as a next line, convert it into integer. No, we should be able to get it as an integer and we should be able to go to the next line, correct? I mean, we should be able to get the next line. That's the documentation. Okay, anyway, if this is how it is working, this is how it is working. Because apparently we are typing the characters on the next line. So the cursor has to be made to go to the next line. But this is little, okay. Int n, sc dot next int, the first int, next line. Okay, let's see. Okay, we have gone through the code. Let's test some other cases. Run it. Okay. Okay, now let's run it with, how much did you give? 5. Dog, race car, okay, nothing common. Car, it's printing an empty string, no? Okay, it should work in almost every case. Let's test it. Yeah, it's 100. So now what I can do is, we'll give you this code in case you want to look at it. Can we give that code? Okay, so look at this code. It does a bit of string manipulation. We are doing everything on strings. So the point is, we took a smallest string as our reference string, then walked through all other strings, taking one character at a time from all the strings, starting. The moment we found that that character is not matching, we did a break and we used a flag to tell us whether we came out of the inner for loop successfully or unsuccessfully. Inner for loop, if you come out successfully, we said our flag will remain true. And if the flag remains true, then this character can be added to our result. If the flag is false, that means something is gadbad. It's time to come out. We just say break from outer for loop also and come out. And outside we just print the result string. That's all. There is no more complexity in the code than this. Only thing is, you have to get familiar with working with strings, caret, and how to iterate through a string. That is just a length. So, okay, we'll do more. I think today we have run short of time. Okay, we'll stop here for today.